Hello everybody, in this video we are going to learn on how to measure earthquakes, and there are three major ways to measure earthquakes. The first one, we can measure the damages caused by an earthquake, and the second one, we look at the amplitude of the seismic waves, and the last one, we measure the energy released by an earthquake. So these are the three alternative ways to measure earthquakes. And we're going to start with the first one, which is called the modified Mercalli intensity scale. This scale measures the effects or damages caused by an earthquake at a particular location. So for example, here, the intensity of 6 to 7 is something that can knock down a bookshelf, for example, and the intensity of 10 or greater than that would represent earthquakes that can damage, major buildings or major infrastructures, as illustrated by this picture right here. And this is a real example of modified Mercalli intensity scale for the 2011 Virginia earthquake that has about magnitude of 5.8. Okay, and Virginia earthquake has a shades of yellow and green right here in this picture right here. So therefore, it falls into the intensity of, in between 5 to 6 maybe. Okay. The next two examples would be part of magnitude scale, and in order to generate magnitude scales, we use the maximum amplitude of ground motions, typically measured by a tool called seismograph. Okay, and seismograph will generate a chart like this, and this is called the seismogram. Okay, as you can see here, this picture, this plot right here is, this is the condition before an earthquakes, and this is the condition after earthquakes. Okay, so the way seismograph works is that it has a weight, okay, or a mass right here that can moves freely, and during earthquakes, the vibrations of the ground, okay, the ground motion will cause this mass to basically goes up and down and write on the chart on the roll paper next to it. Okay, and this concept will again generate a seismogram. All right, so Richter scale is the second type of scale. So the first one is the modified Mercalli intensity scale, right? The second one is called the Richter scale. Richter scale measures the log of the amplitude of the largest wave received on a seismograph, and it works best in location near epicenters. And if we go farther away from epicenters, then these measurements become unreliable because of because it's getting harder to read the seismographs. And then the scale is logarithmic. Increase 1 unit equals to 10 times greater shaking, and earthquakes less than magnitude of 2 are not usually felt by people. And this Richter scale is discovered by a person named Charles Richter. And the last type of scale that we have is called the moment magnitude. Moment magnitude measures the amount of energy released by an earthquake. Okay, and this would be the simplification of the formula used to measure the moment magnitude. It basically incorporates three major factors. The first one is the strength of the rocks. Okay, measured by the shear modulus right here, and the second one is the area of the rocks that broke, or the rupture area, and then it also takes into account the distance of the rocks move along a fault. Okay, so because these are measurements, this becomes the scale that is mostly accurate, all right, and more reliable. Okay. This plot right here tells you or gives you some illustration of how common earthquakes are within the earth. Okay, these are the number of earthquakes that occur every single year, and the ones that occur are mostly very small. They probably have about magnitude 2 or 3, right? As you can imagine here, we have 1 million of magnitude 2 earthquakes that happen every single year. Now, luckily, we have much less of big earthquakes that happen every year. Okay, so here, for example, some of the biggest earthquakes that ever recorded in our history. The biggest one being the Chile 1960 right here, the one that happened. Look at this. This is the intraplate earthquake that we talked about in previous video. This is the New Madrid earthquake that happened in 1812. All right, and this would be slightly bigger than the world's largest nuclear test by the USSR. Okay, so so hopefully that shows some illustrations on how common earthquakes are. Again, some smaller earthquakes are very common, but of course they are too small to be felt by humans. But luckily we also have bigger earthquakes, but luckily they do not occur as often as the small earthquakes. In order to locate an epicenter, we need to at least have 3 seismic stations, because each of the station will analyze the difference in arrival times of P and S waves at several different seismometer here. And each of the seismograph or the seismic station will generate a circle that illustrate the distance of the epicenter from that seismic station. So in order to locate an epicenter, we need to at least have 3 seismic station. Here I have, in this example, I have 1, 2, and 3 seismic station, and each of the seismic station has their own circle, and where the 3 circles meet or intersect, that would be our location of the epicenter. Okay, so don't forget about that, that we need to at least have 3 seismic stations to determine the location of an earthquake. Okay, and that's it for this video, and I'm going to see you again in the next video. All right, bye bye.